Okay, this is activity 3 for 6.2. We're going to be going through and actually graphing some data. Okay, so it says we're going to work with the partner, graph the data, and we're going to graph to test the truth of each statement. If the statement's true, we're then going to write an equation that shows how to obtain one measurement from the other. So the first scenario says, you can find the horsepower of a race car engine if you know its volume in cubic inches. So they've set up the graph for us with all of the axis numbers, and they've labeled the axis lines. So the first one says the volume is 200. So this is our x's, this is our y's, x, y. So I'm going to go over to 200 and then up to 375, which would fall. Each of these boxes looks like they're worth 100. Okay, so 375 is going to be just under 400, about a fourth of the way there. Okay, so there's one of our dots. The next one is over to 350 up to 650. So over to 350, so this would be 300. So 350 is going to be in the middle of this box, and then up to 650. So 650 would be somewhere in here. Okay. And then 350 and 250. So over to 350, so still in the middle, up to 250 would be in the middle of this box. And then over to 500, so this is 500, up to 600. Okay, did we end up with a line? No, we ended up with kind of points all over the place. So in this situation, can you find the horsepower of a race car? No, there's no, in order for us to determine, we would have to have a pattern. So this would be a no, or a false statement. However you want to go through and answer that. Okay, so let's go ahead and look at B. You can find the volume of a race car engine in cubic centimeters if you know its volume in cubic inches. So let's go through and graph each of these. So over to 100. So each of these lines going across is worth 100. So that's 100, that's 300, that's 500. So I'm just putting those smaller numbers in there. And then it looks like each box here is worth 1,000. So this is 1,000. This would be 3,000. This would be 5,000. This would be 7,000. Sometimes I need that visually as they're doing some skipping. Okay, so we're going to go over to 100. So here's our 100 and up to 1640. So let's see, this is 1,000. So 1640 is about in the middle. So somewhere in there. Okay, so over to 200. Up to 3,280. So here's 3,280 is maybe about the fourth of a way up there. And then over to 300, up to 4,920. So just a little under 5,000. Okay, so there we do have a line. So in this scenario, I would say that this would be a true statement. Okay, so now we're going to try and figure out what are they doing to get that. So this is what it looks like. So seeing it more as a left to right, I prefer when I'm trying to find what they're doing to X to get Y. I like to see it left to right. Okay, so let's see. Well, if we're adding a huge number. So let's try multiplying first, which it's hard to kind of see. So I'm going to work backwards. And I'm going to take 1640 and divide it by 100 to see what I would take 100 by. So 1640 divided by 100 is actually going to move my decimal over 2 places. So could it be that we're taking it times 16.4? So let's check that on the 200. If I do 200 times 16.4, that gives me 3,280. That gave me the answer. So we're taking it times our equation is y equals 16.4x. Okay, I always start with the simplest ones and then work my way out. So I tried the adding first, which I knew that was going to not be right because it was a huge number. So I tried multiplying, which I had to do division to see what I'd multiply by. Okay, so you guys should be able to work your way through activity 4 because it's doing the same thing. They're asking you, they're just giving you more things to graph. So you guys will work through activity 4 on your own and you can check that one off of the answer key. So good luck with activities 3 and 4.